Okay, so today we're diving into something really cool from Google DeepMind. They've published a paper that might just solve one of the trickiest puzzles in AI image generation. How do you get those incredibly detailed images without, needing a supercomputer for every single one? Let's get into it.
I mean, seriously, just look at what these AI models can pull off now. You can ask for a photorealistic kitten or a panda catching a wave, and it just makes it. It's absolutely wild. But to make that magic happen, there's some really fascinating science going on under the hood.
So that's the million-dollar question, right? How in the world does a machine translate a simple phrase, like a panda surfing, into a complex, beautiful picture? Well, it all starts with a fundamental challenge that every single one of these models has to face.
And we can think of that challenge as the AI's Goldilocks problem. It's this constant search for a summary of an image that's not too simple, not too complex, but, you guessed it, just right. To get this, we have to talk about something called latents. Now, don't let the word scare you. Just think of a latent as the AI's internal sketch of an image. It's a compressed, numerical summary, like a kind of mental shorthand that holds all the essential info about the picture. This is the thing the AI actually learns from. And here's the classic trade-off. If you make that latent summary too simple, sure, it's easy for the AI to learn, but you lose a ton of important details, and you end up with a blurry mess. But if you make it too complex, you keep all the details, but now it's incredibly hard and super expensive for the AI to learn from. And you can see that exact problem right here. On the left, the summary is way too simple, and we get this fuzzy, low-detail toucan. The sharp, high-quality image on the right, that requires a really complex latent that's just a nightmare for the AI to work with. The real goal is to find that sweet spot, that just right balance in the middle.
And this is where the big breakthrough comes in. The folks at Google DeepMind have come up with a really elegant solution to this whole Goldilocks problem.
They call it Unified Latents, or just UL for short. And it's a completely new framework designed to give us the best of both worlds. Really high-quality images from latents that are actually pretty easy for the AI to learn.
The big idea here is kind of genius. Instead of getting stuck in that trade-off, simple versus complex, UL just changes the rules of the game. It trains the part that creates the sketch and the part that acts as the artist at the exact same time, so they learn and adapt to each other.
So how does this actually work? Let's break down the 3 key ideas that really make this whole system click. Okay, so the system has 3 parts that work together, and they're all based on diffusion, which is that cool technique where an AI starts with noise and slowly refines it into an image. First, an encoder makes that latent sketch. Then, a diffusion prior cleans up that sketch, kind of making sure it's organized and makes sense. And finally, a diffusion decoder takes that polished sketch and turns it into the final image. The crucial part? They all learn together as one big, unified system.
The real magic in the paper comes down to 3 things. First, that initial sketch is made with a very specific, predictable amount of noise. Second, the part that cleans it up, the regularizer, is built to handle exactly that level of noise, no guesswork, which makes everything simpler. And third, the artist part is trained to focus only on the important stuff you can actually see, and to just ignore the tiny, invisible noise that doesn't really matter for the final picture.
So, that all sounds great in theory, but, the proof is in the pudding. Does it actually perform any better? Let's take a look at the data.
And wow, the numbers here really tell the story. Let's look at that FID score. It measures image quality, and for this, lower is better. Unified Latents gets a 4.1. That blows past models trained directly on pixels. And get this, it's way better than a super popular model like Stable Diffusion, which comes in at 6.8.
But here's the kicker. Quality is only half the story. Efficiency is the other half. This chart shows the training cost, which is basically how much computer power you need. And you can see UL is getting these top-tier results while using way less power than the other guys. The takeaway is simple. It's not just better, it's also cheaper to run.
The researchers themselves put it perfectly. They said that UL is basically the most efficient approach out there when you're balancing how much it costs to train against how good the final result is. In the world of massive AI models, that is a huge, huge deal.
Okay, so the numbers are really impressive, I get it. But what does that improved quality actually mean? What can you see that's different?
And this is what it looks like in practice. On the left, you've got a standard model trying to recreate an image of a bus. And look, the text just turns into a blurry smudge. But on the right, with Unified Latents, those fine details are preserved. You can actually read semi-rapido on the side of the bus. That's the real-world difference we're talking about. It's night and day.
And this whole framework isn't just for still images.
When they applied it to generating video, it scored a new state-of-the-art record, a 1.3 FVD. That's a key metric for video quality, and it just proves how powerful and flexible this whole idea really is.
So, why should we care about all this? Why is this such a big deal? Well, this breakthrough is about so much more than just making prettier pictures.
The takeaways here are massive. First, you get more efficient training, which saves time, money, and energy. Second, you get higher quality images and videos with sharper details. Third, researchers now have a systematic way to control that classic quality versus complexity problem. And finally, this isn't just for images. This framework could potentially be used for all sorts of things, like audio or even text.
And at the end of the day, all of this just unlocks even more creative potential. It lets these AI models learn the building blocks of our world more effectively, and that leads to more detailed, more coherent, and way more imaginative results, like this amazing frog wearing a sweater.
And that really leaves us with a fascinating question for the future, doesn't it? Now that AI can learn so much more efficiently, what new creative frontiers are about to open up? What amazing things that seemed impossible just yesterday are now right around the corner?